Hey guys, I hope you guys are doing well. I am at home with my daughter. She had a really bad asthma attack and I'm trying to get her breathing under control. So I am coming at you guys from the computer. Today we're going to use what we've been learning about solving systems to help us solve some word problems. Now, you guys will see a lot of word problems in this class, but also when you go on to take SAT, ACT, standardized tests love to use word problems. So we're going to learn how to use systems of equations to help us solve word problems. All right, if we look at the first word problems, I told you guys before in the beginning of school, always read the problem first. Once you've read it, then go ahead and see if you can write an equation for it. So it says, use a system of equations to solve. Example 1. One number is 5 less than a second number. Twice the second number is 2 less than 5 times the first. Find the two numbers. Now, there's several important things in here, but I want to remind you, whenever it says is less than, you have to remember to switch the way they're written. So you switch the order in which they're written. All right, and you always want to quantify a variable. So I'm going to call one number x. So number 1 is going to be x. And the second number, or number 2, is going to be y. All right, now let's go ahead and write our equations. So for the first equation, it says one number. We just said let that one number be x. Then it says is, we know is in math is an equal sign. 5 less than. We said less than is a subtraction, but you have to switch the order. That means whatever's written first, which in this case is a 5, is going to come behind the minus sign. And we said whatever comes after the less than is going to be written first. So what's behind the less than is our second number, which we're calling y. That is equation 1. All right, now going on to our second sentence. Twice the second number. Well, we just said y is going to be the second number, so it's going to be 2 times y is, and then we have another less than. So whatever comes before the less than is going to come after the minus sign, and whatever comes after the less than is going to come before. And it says 5 times the first. Again, we let x be the first number, so it's 5 times x, or just 5x. And let me see if I can clean this up a little bit so it looks a little bit nicer. All right, now that we have our two equations, I'm numbering them, equation 1 and equation 2. Now, I told you guys before, when solving systems, you can use whichever method you choose. You can graph, you can use substitution, or you can use elimination. But I do want to mention, sometimes the problems are set up so that you use one over another. In this one, because the x is already by itself, substitution is the easiest method to use in this case. So I'm going to go ahead and use x equals y minus 5 and plug the y minus 5 into the other equation. So equation 2 is 2y equals 5x minus 2. And I'm going to substitute that y minus 5 right here in place of the x. Now that we've substituted, we can go ahead and solve for our y. We're going to do the distributive property. We get 2y equals 5y minus 25 minus 2. We go ahead and we're going to move the y to one side by subtracting it. And I always like to show out these steps because some of us are careless with signs. You always want to make sure your signs are correct. 2 minus 5 is negative 3 y's. And negative 25 minus 2 is negative 27. As a last step, when we divide both sides by negative 3, negative 27 divided by negative 3 is a positive 9. Once you find the first variable when you're doing substitution, it's easiest to go back in where that first variable was solved for. So here where it says x equals y minus 5, we're going to go back to that equation. In a place of y, we're going to put 9. And finally, we do our subtraction. 9 minus 5 is equal to 4. So the solution to that one was 4, 9. All right. All right, so that was our first type of word problem where you're given equations in words. Now, a lot of times you'll see word problems that deal with distance and time. So if we look at example 2, let's read what it says first. 2 trucks leave a city and head in the same direction. After 7 hours, the faster truck is 56 miles ahead of the slower truck. Find the slower truck has traveled 301 miles. Find the speed of the 2 trucks. Now, a couple of important things here. First of all, it says the time is 7 hours. It says the faster truck is 56 miles ahead of the slower truck, and the slower truck has traveled 301 miles. And if we identify, so this right here is our time. This one is part of our distance. And they ask us to find the speed. A speed is a rate. So really, just identifying kind of what they've given us tips us off that we need to use the equation distance equals rate times time. Now, we have 2 different trucks and they're traveling at 2 different speeds. So we're going to have different distances and we're also going to have different speeds or different rates. So I'm going to have a rate 1. The times are both going to be 7 hours and I'm going to have a distance 1. And then I'm going to have a second distance, which is going to be a little farther. And I'm going to have a second rate, which is going to be faster. Now, we need to solve for the rates in both of these equations. So if you wanted to, you can do this one of 2 ways. You can either in the beginning right now, go ahead and divide both sides by your time. And our time is 7 hours, so we'll end up plugging 7 in. If you don't like to do it while you're still using variables, you could plug your numbers in and then divide out the time. So what our equations look like, our first equation is rate 1 equals distance 1 over time. Our second equation is rate 2 equals distance 2 over time. So again, you can solve it for the rate first and then plug your numbers in, or if that confuses you, you can plug your numbers in first and then solve it for your rates. All right, let's go ahead and plug our numbers in. So let's use this first equation for our slower truck. Now in both of our cases, our time is going to be 7. So I'm going to go ahead and plug 7 in place of our time. It says the faster truck, so we're going to use this for our fast truck and this one for our slow truck. All right, so it says the faster truck is 56 miles ahead of the slower truck, and the slower truck has traveled 301 miles. So let's take this slow equation right here, and we're going to plug 301 in place of our distance. So it's going to look like this. R1 equals 301 miles over 7. Well, that's easy. If we go ahead and divide 301 by 7, we're going to get 43 miles per hour. So those were in miles. This is in hours, so that's miles per hour. For our second truck, the faster truck, It says that it is 56 miles ahead, so it's 301 miles plus 56 miles. If it's 56 miles ahead, it's going to be, you just add them together, divided by the 7 hours. That's going to give us 357. Oops, sometimes that moves on me when I'm doing this. That's going to give us 357 over 7, which will give us 51 miles per hour. So the speed of the slower truck is going to be 43 miles per hour, and the speed of the faster truck is going to be 51 miles per hour. And that is how to do an example of using distance equals rate times time to find a speed of 2 trucks. All right. The next type of problem you'll see often involving systems deals with cost and revenue. So this is a very simple model. In the business world, equations get a lot more complicated. But for our purposes, we're going to say that the cost is what is spent to produce. The revenue is what's made when you sell. And the break-even point is where the cost and the revenue are equal to each other. Now notice these are written in function notation. So whenever you see a capital letter and then parenthesis X, that is function notation. So C, it tells you the function C is the cost function. X tells you that is that's the variable that you plug in for X. And finally, this should make sense, but when cost is greater than revenue, the company loses money. If revenue is greater than cost, the company makes money. And that break-even point is important because it tells the company, hey, you need to sell X amount of product, and once you sell that amount, anything you sell in addition will make you revenue. So the break-even point is very important in the business world. Again, equations in the business world get a lot more complicated. So this is just a very simple equation. All right, let's see an example of that. So on example 3, and I apologize, these got cut off, but on example 3, it says a gift box manufacturing company recently purchased $1,000 worth of new equipment to make gift boxes to sell. The cost of producing a package of gift boxes is 50 cents. And the package is sold for $3. Find the number of packages that must be sold for the company to break even. So we're looking for their break-even point. We're looking for where their cost of X is equal to their revenue of X. So notice that I did color code them. So I put our cost in black. I underlined them in black. So it says our cost of X, where X is the number of packages. I always like to identify what my variables are. So X is the number of packages. We had to purchase first $1,000. So that's a cost. That's a fixed cost. And then it says the cost of producing a package of gift boxes is 50 cents. So it's 50 cents per package produced. So 50 cents times X. Doing our next equation, it says the package is sold. So here's where our revenue comes in because we're selling stuff for $3. So it's $3 per package. Find the number of packages that must be sold for the company to break even. All right, to find their break-even point, we can set the cost function equal to the revenue function. So essentially, we just drop that, and we drop that, and we set the two equations equal to each other. Oh, sometimes it won't let me move up. Here we go. All right, so let's go ahead and set them equal to each other. We're going to have 1,000 plus 0.50x equals 3x. And you can see this is a pretty basic equation to solve. If we subtract 50.50x from both sides, we're going to get 1,000 equals 2.5x. And finally, if we divide both sides by 2.5, we're going to get a total of 400 packages. So what that tells the company is, hey, you need to sell 400 packages and then you break even. And at that point, anything greater than 400 packages is going to make the company money. Anything less than 400 is going to cost the company money. All right, our last example is going to deal with solving systems with 3 variables. So let's go ahead and read the last example together. It says, find the value of A, B, and C such that the equation y equals ax squared plus bx plus c has ordered pair solutions -3, -37, -2, -22, and 1, -1. All right, so it says that these are solutions. That means if you plug them in, they make the equations true. So we need to find what the original equation is. So whenever you have a problem like this, what you want to do is make a couple of equations using those numbers. So here's the bones to our equation. And we're going to replace all of our x's with these ordered pairs and all of our y's with the other numbers associated with them. So we're going to end up making 3 equations using that first equation. So in the first case, y is -37 equals a, x is -3. So I'm going to replace our x's with -3. And then I'm going to clean it up a little bit. So if we go ahead and simplify that, first do order of operations. -3 squared is a +9. So we're going to have -37 equals 9a minus 3b plus c. All right, we've done the first point. Let's go ahead and do the second point. I'm going to cross it out because it's done. For the second equation, notice I numbered my equation. We're going to plug in -22. And let me get a different pen and I'll pause this while I'm getting my pen set up. Okay, got my pen set up. So for the second one, y is -22. X is -2. So I'm going back to that y equals ax squared plus bx plus c. And again, I'm just replacing -2 in for x, and I'm replacing -2 and 22 in for y. And then I simplify, always using order of operations. -2 squared, -2 times -2 is a +4. -2 times b is -2b. And finally, for our third equation, I'll do that one in orange. Let's see if you guys can see this one. I'm going to cross that one out. It's done. So in place of y, I'm going to put -1. In place of x, I'm going to put +1. All right. And simplify. That's going to give us a plus b plus c. All right, so we're going to use what we learned last Friday. So remember, on Friday, you're going to set up 2 sets of eliminations. Now, we can choose any variable to eliminate. Let's go ahead, because all of the c's are 1s, let's go ahead and eliminate c. And the equation that we're going to reuse is going to be equation 3, because all of our coefficients are 1. So again, you can eliminate whichever variable you want. I'm going to choose to eliminate c. So I'm going to do equations 1 and 3, and then I'm going to do equations 2 and 3. So again, I said I'm reusing equation 3 because it's the simplest, and I'm choosing to eliminate C because the coefficients are all 1. Now, in both cases, what I can do to make C the opposite is I'm just going to multiply equation 3 by -1, and I'm going to rewrite equations 1 and 2 just like you see them. So equation 1 is -37 equals 9a minus 3b plus c. We said on equation 3, we're going to multiply it by -1 first. A -1 times a -1 is a +1. And all of our variables are now going to become negative. All right, now that we've set that up, let's go ahead and do what the numbers say. -37 plus 1 is -36. 9 minus 1 is 8. -3 minus b is -4b. And the c's are going to cancel each other out. And we said on Friday, number your new equations 4 and 5. So this one is equation 4. We're going to go ahead and write down equation 5. All right, for the next set of eliminations, we are going to go ahead and use equations 2 and 3. Equation 2, we're going to leave as it is. It's -22 equals 4a minus 2b plus c. Equation 3, we said we have to multiply it by -1 to make it the opposite. So I'm going to use this one right here where I multiplied by -1. Or actually it didn't, but okay. When we multiplied by 1, a negative times a negative is a +1. And then all of our variables, remember, became negative. All right. Now we go ahead and add and subtract. -22 plus 1 is a -21. 4 minus 1 is 3a's. And -2 minus 1 is -3b's. And like we saw with the last one, the c's cancel. And that is equation number 5. All right. Once you've eliminated the same variable, you have 2 new equations. And you're going to take those 2 new equations and you're going to eliminate one of the variables. Now, let's see, for the A's, we have 8 and 3. The first number that they have in common is going to be 24. For the B's, we have 3 and 4. The first number they have in common is going to be 12. So let's go ahead and eliminate B. If you want to eliminate A, you can. So I'm going to multiply this first equation by -4. I'm going to multiply the second equation by 3. Now I did have to do one of them negative. It does not matter which equation I choose to be negative, but we do have to do negative because they're both already minus. So, oh, I meant to highlight that. The highlighter looks similar to my eraser. So because they were both minus, I did have to choose one to be negative. It doesn't matter which. All right, let's go ahead and write these down. So if I multiply it by -4, that's going to give us +84 equals -12a plus 12b. So that's our new equation 5. We just multiplied it by -4. I'm going to multiply equation 4 and bring it right down below so we can do our subtraction. We've got 36 times 3, which gives us 108. But it's going to be negative. 8 times 3 is 24a. And -4 times 3 is -12b. Again, when you're doing elimination, one should be the exact opposite of the other. If it's not, go ahead and look back and see what you multiplied by and fix it. And that's why I always like to write my steps so that I can easily go back and see what I've done wrong. All right, if we go ahead and do 108 and 84, we're going to get -24. Negative 12 plus 24 is going to give us a positive 12a, and the b's cancel out. So when you do equations 4 and 5, you should get it down to one variable, and you should be able to solve that one variable. When we divide by 12, our a is going to be negative 2. The most logical place to go back in is that space underneath either equation 4 or 5. We have space below equation 4, so I'm going to replace a with negative 2. So it's going to be, negative 36 equals, sorry guys. Okay, negative 36 equals 8 times negative 2 minus 4b. That's going to be negative 16. If we add 16 to both sides to solve for our b, we're going to get a negative 20 equals negative 4b. And when we divide both sides by negative 4, we get b equals 5. All right, once you've solved for the first two equations, go back to one of the originals. And I do like to use the easiest one. So for me, I would use equation 3 and go ahead and replace a with negative 2, b, so let's go ahead and write it down. A with negative 2, b with 5, and then solve for c. You can use any one of the originals, but this one is actually the easiest one to use. But if you use one of the other ones, you should get the exact same answer for c. All right, 5 minus 2 is 3. Now, again, I know a lot of you guys like to skip a bunch of steps, but do write some of it out because it's very easy to make a sign mistake. And I could see a lot of you guys adding the 3 in that case instead of subtracting it. So always be very mindful of your signs. Negative 3 minus 1 is negative 4. So let's go back and answer our original problems. So we wanted to know what the equation was. It's y equals ax squared plus bx plus c, where we're going to plug our numbers in. Y equals negative 2x squared plus 5x minus 4. So I just replaced a, b, and c with the 3 numbers that we found that they equal. All right, we've got one more problem. I'm not sure what my time is. If this goes over though, guys, you can access the rest of the video via Moodle. All right, going on to example 5. A store sells tents, sleeping bags, and camp stools. A customer buys a tent, 2 sleeping bags, and 5 camp stools for $138. The price of the tent is 9 times the price of a camp stool. The cost of a sleeping bag is 13 more than the cost of a camp stool. Find the cost of each item. All right, so quantify your variables. Let's let t equal tent, of course. Let's let s, actually, we'll use b because I know my s's look like 5s. So let's let b equal bags, sleeping bags. And let's let c equal camp stools. All right, so it says a customer buys 1 tent, 2 sleeping bags, and 5 camp stools for $138. That's our first equation. Then it says the price of the tent is 9 times the price of the camp stool. The cost of the sleeping bag is 13 more than the cost of the camp stool. So here we have 3 equations. Now, This is kind of like the last examples that I did on Friday, where these we can use what we have to go ahead and solve. So the bag is 13 plus C. The tent is 9 times C. So what we're going to do first is we are going to go ahead and take this equation and substitute it in to the first equation. So I said generally I like to use elimination on these, but sometimes if one of the variables is already solved for and it makes sense to substitute it in, I will go ahead and substitute it in, because think about this. If I replace t with 9c in the first equation, we'll have a b and a c, just like we do on equation 3. So what we're going to have is 138 equals 9c plus 2b plus 5c. We can combine like terms. Nine plus 5 is 14c. And now we have two equations that have both a b and a c. So I'm going to do one more substitution. In place of b on that equation, I'm going to sub in 13 plus c. So we're going to have 138 equals 14c plus 2 times 13 plus c, and that will give us c. We're going to distribute. 2 times 13 is 26, and 2 times c is 2c. We're going to go ahead and combine our like terms. I'm also going to subtract that 26 from both sides. Oh, sometimes it doesn't want to let me move it, so I'll move it like that. All right, it's 138 minus 26 is going to give us 112. And if we add the c's together, we're going to get 16c. If we divide both sides by 16, we're going to get 7. Now, because this problem is a lot simpler than some of our others, once you solve for one of the variables, it's all super easy from there. So I'm going to go ahead and replace our c's with 7, and that's going to give us our other numbers. So we're going to have t equals 9 times 7, which is going to give us 63. And finally, for the third equation, if I replace c with 7, the sleeping bags are $20. So sleeping bags are 20. The stools, camping stools, are $7. And finally, the tents are $63. And that is how to use variables or systems of 3 variables to solve. All right, finally on example 6, and again, if we run over time, you can watch this at home. Now, on these questions that involve chemistry and mixing a solution, I found that it's easiest to make a table. And this is something that you guys can use in chemistry. And for those of you going on to pre-calculus, you'll be doing this, or you'll be doing this in pre-calculus as well. Let's read the question. A pharmacist needs 70 liters of a 50% alcohol solution. She has available a 30% alcohol solution and an 80% alcohol solution. How many liters of each solution should she mix to obtain 70 liters of a 50% alcohol solution? Now, I've gone ahead and set up a table, and you can use this table on any type of these problems where you're mixing percentages of solutions to try to make a total volume solution with a specific percent concentration. So this is what the table looks like. So I've set it up. On the left side, you put your percent concentrates. So the 2% that they gave us on here were a 50% solution and a 30% solution. So I'm going to go ahead and plug in 50% and 30%. It said we need a total of 70 liters. So notice where I have total, it says what we want. We want a total of 70 liters. So we're going to call the first 50% concentration, we're going to use T. I always use T for these problems. Well, if 1 is T and we have another percent that we're adding in, we want to make a total of 70. The second one would be 70 minus T. So if you're adding a certain amount of the first concentrate and you want it to add to make 70, you could just subtract that first concentrate from 70 to get the second amount of concentrate. We said that we want the total to be, the total of 50. I totally did this wrong, guys. Okay, the total we want to be 50%, and she has available a 30%, so always check that your numbers are right because I put them in the wrong space. The total was 50. We want part of it to be a 30% solution and an 80% alcohol solution. All right. Then if you look on over here and here, I tell you what to do. So for these, you add down. If we add T and 70 minus T, the T's will cancel out, giving us our total of 70. Then where it says percent in decimal, you're going to put your percent in decimal. 30% is 0.3. 80% is 0.8. And finally, what we want is 0.5. You do nothing in the middle column. Finally, for the total, it says multiply across. So we're going to have T times 0.3, which is just 0.3T. We're going to have 70 minus T times 0.8. So first we multiply 70 by 0.8, we get 56. And then we multiply 0.8 by negative T, which is negative 0.8T. Finally, if we multiply across here, half of 70 is 35. Finally, it says to add down. And where I always put this is below the directions. So I'm going to go ahead and add down and put it, let's do it in green, put it right here. So we have 0.3T plus 56 minus 0.8T equals 35. So again, take this whole row, whole column and put it down there, just to add them down. Again, I teach you this way because you will see this. Those of you going on to pre-calculus, this is how they teach it in pre-calculus. So I'm trying to keep it cohesive. All right, now you can see we have one variable to solve for. So we go ahead and we combine our like terms. We combine the 0.3 and the negative 0.8, which gives us a negative 0.5. We're going to subtract the 56 from both sides. Notice both of these will become negative. It's going to be a negative 0.5, I forgot my T, equals 35 minus 56 is going to give us a negative 21, and we divide negative 21 by negative 0.5, we get a positive 42. All right, now that we've solved for T, the last step is just to go ahead and plug it in. So of the 30%, if T is the 30%, we said T was 42. So we need 42 liters of the 30% concentration. To solve for the 80% concentration, we replace our T with 42, and we subtract. 70 minus 42 is going to give us 28 liters of our 80% concentration. And that is how to solve one of these concentration type problems. Again, I like to make the table because it just helps. You can generally multiply across, add down, and then that gives you an equation, and that equation only has one variable. Now there is more than one way to solve this, but again, I'm trying to keep it cohesive since many of you guys will be going on to pre-calc next year, and this is how they teach you in pre-calculus. All right, guys, that's it for today. That is how to use systems of equations to solve word problems. I hope you guys have a blessed day. Pray for my daughter, and hopefully I will see you guys soon. Vetter out.